Hello viewers, welcome back to Massive Open Online course on 3D printing and design for educators. This is lesson 7.3 on variants of powder-based 3D printing processes. The intended learning outcome is, after going through this video, you will be able to classify the variants of powder-based 3D printing processes. So let's start with the variants of powder-based 3D printing processes. As discussed, powder-based 3D printing processes are classified into two types: powder bed fusion techniques and laser powder fed or direct energy deposition techniques. At the heart of powder bed fusion is selective laser sintering. Along with SLS, the other variants of powder bed fusion are direct metal laser sintering (DMLS) or selective laser melting (SLM). Next is electron beam melting (EBM) and binder jetting. These methods refine SLS, offering different benefits like stronger parts and more material options. Laser powder fed or direct energy deposition methods such as laser blown powder use laser to melt metal powder onto surface. This lets us fix, coat or make metal parts with precision. Laser engineered net shaping expands on this by making fully solid metal parts with complicated shapes. Direct metal laser sintering is tailored for sintering metal powders rather than polymers. DMLS facilitates the fabrication of intricate metal components suitable for aerospace, automotive, and medical sectors, where robust metal parts are essential. Next process is selective laser melting. Selective laser melting is closely related process to DMLS. The laser completely melts the metal powder instead of sintering it, resulting in fully dense metal parts with superior material densities and mechanical properties. The next variant of powder bed fusion is binder jetting. Binder jetting is a 3D printing method used to make objects by putting a binding substance on a bed of powder material layer by layer. A special printer drops liquid binder onto a layer of powder following the shape of the object being made. The binder, usually a liquid glue, sticks the powder particles together where it is applied. This process is guided by digital design sliced into thin layers, controlling where the binder goes. After one layer is done, more powder is spread over it, and the process repeats layer by layer until the whole object is formed. By applying binder selectively, the object's shape is built up within the powder. Once printing is done, the green part is taken out depending on what material is used and what properties of the final parts needed. Further steps like curing for polymers or sintering for metals and ceramics or surface finishing might be needed. The next powder bed fusion technique is electron beam melting. In electron beam melting, metal powder is selectively melted layer by layer using an electron beam to create complex 3D objects. An electron beam generated from a highly focused electron gun is directed onto the metal powder bed. This beam moves according to the programmed path, selectively melting the powder in specific areas corresponding to the cross-section of part being manufactured. Electron beam melting is performed in a low-pressure vacuum environment, with a small amount of inert gases used to remove gaseous byproducts and oxygen. In this process, the powder is heated by transfer of kinetic energy from incoming electrons to the powder particles. EBM offers several advantages, including ability to produce complex geometry, high material utilization rates, and excellent mechanical properties due to the fully dense parts it produces. Now, the next process is laser engineered net shaping process. This process is from direct energy deposition where powder is supplied through nozzle. Laser engineered net shaping technology uses computer-controlled lasers to weld air-blown streams of metallic powders into the custom parts and manufacturing molds within a short time frame, eliminating the need for extensive machining. Lens is particularly suited for producing small lots of high-density parts or molds. In operation, metal powders are propelled through nozzle towards a central point beneath them, where they intersect with a focused laser beam. This laser beam imparts intense heat, melting the metal powders and causing them to fuse onto a substrate or previously deposited layers. As the laser and powder jets remain stationary and the model or its substrates are systematically moved to provide new areas for metal deposition layer by layer until the desired 3D geometry is achieved. So, these are the few important variants of powder-based 3D printing processes. To summarize, in this video we have briefly discussed about the variants of various powder-based 3D printing processes like direct metal laser sintering, selective laser melting, binder jetting, electron beam melting, and laser engineered net shaping. So thanks for watching this video. Wish you happy learning.